All right, let's talk about something that sounds super complicated, but it's actually all around us: neural networks. We're going to break down what they are and, how they quietly power so much of our modern world. Let's dive in.
So, let's kick things off with a big question. What if computers could actually learn the way we do? I mean, not just by following a rigid set of instructions, but by watching, seeing patterns, and getting better with experience. Well, that's the big idea we're digging into today.
You see, the whole concept of a neural network is inspired by the most complex thing we know, the human brain. On one hand, you've got our own biological web of neurons, and on the other, you have this artificial version, built with code. And this artificial brain, it's the powerhouse behind some of the smartest tools you use every single day.
Okay, so let's get into our first section, computers that think like us.
So what is a neural network, really? Let's forget all the confusing jargon for a second. At its heart, it's just a system made of different layers. Each layer grabs some information, does one specific job with it, and then passes its work on to the next layer in line. It's all about breaking a huge problem down into tiny, manageable steps.
To make this even clearer, let's use an analogy. I want you to think of it as a kind of digital assembly line.
Just picture it, a giant factory floor, right? You've got this long assembly line with a whole team of workers. Now, each person doesn't build the entire thing. Nope. They just do one small specific task before sending it down the line to the next person.
And here's how that factory idea connects back to a neural network. You start with your input data. Let's say it's a picture. The very first layer, the first worker, might just look for simple things, like basic edges and shapes. The next layer takes those shapes and combines them into something more complex, like an eye or a nose. And it keeps going like this, layer after layer, until the very last one makes a final call, like, yep, that's a cat. Each layer adds its own little piece to the puzzle.
Okay, but wait, how does this digital assembly line actually get smart? How does it even know what it's supposed to be looking for? Well, that's where the real magic happens, learning from examples.
The basic flow is always, and I mean always, the same. You give the network an input, it chews on it through all those processing layers, and then it spits out an output. But here's the kicker, the really important part. What happens when that output is wrong?
And that is the absolute core of what we call machine learning. Honestly, it works just like teaching a toddler the difference between a cat and a dog. You don't give them a textbook with a list of rules, right? Of course not. You just show them picture after picture. Cat, dog, cat, cat. And over time, their brain just starts to figure out the patterns on its own. Neural networks do the exact same thing, just with a mind-boggling amount of data.
Now, you might be thinking this all sounds pretty abstract and futuristic, but I promise you, you've probably used a neural network a dozen times already today. They are hiding in plain sight, right there in your pocket.
You know when your phone just knows who to tag in a photo? Yep, that's a neural network. Or when you ask your voice assistant a question and it actually understands you? That's a neural network too. Those scarily accurate movie recommendations you get? You guessed it, they're literally everywhere.
So what's the secret sauce here? It's scale. We're talking massive, mind-boggling scale. These systems aren't learning from a few hundred examples. They're learning from millions. Millions of photos to learn faces, millions of songs to learn your taste in music. That huge scale is what makes them so incredibly powerful.
And that ability, the power to learn from these insane amounts of data, is exactly why neural networks are the engine driving the whole AI revolution. They let us solve problems in a way we just couldn't before.
This quote really gets to the heart of it. Just think about it for a second. Instead of some poor programmer trying to write code for every single possible accent in the English language, which is impossible, a neural network just listens. It learns the patterns on its own from millions and millions of voices. It lets machines tackle problems that are just way too messy and complicated for traditional programming.
And that's why, seriously, whenever you hear about some big breakthrough in artificial intelligence these days, you can bet a neural network is at the center of it. They really are the beating heart of modern AI.
So when you boil it all down, a neural network is really just a computer learning from examples one little step at a time. And it's that one powerful idea that connects the camera in your phone right now to the self-driving cars of the future.
And that brings us to one last really big thought. These systems are so powerful because they learn from the world of data that we create. Our photos, our voices, our choices. So the question we really should be asking ourselves is this:
If these systems are learning from our world, what exactly are they learning about us?